Alright, so we are going to have some awesome fun today dividing polynomials. Oh no. Hold on. Oh, you can only see my hand. Well, that's not helpful. We are going to be dividing polynomials. And when I say divide, this is the kind of division that I'm talking about.
Long division?
Mm-hmm.
Is it still line? Yeah, still line.
Okay. Let the record show the audience is my students are very excited to do long division. It's their favorite. Okay.
Yeah, no,
Let's, don't look at me like that. Okay. Let's quickly remember how to long divide. Can 5 go into 30? No. Bummer. Can 5 go into 36?
Yes.
How many times? 7. So where does the 7 go? On the top. Okay. Multiply. 7 times 5 is? 35. Then what do I do? Subtract it, and I get 1. Then what?
That's 7.
Yes.
How many
Okay.
times can 5 go into 7? 3.
17.
Yeah.
3. So your answer was still right.
Yeah.
Okay, so 3 times 5 is 17.
15.
So I subtract and I get 2.
Bring down the 5.
Bring down the 5. How many times?
5.
5. And then we bring down the 2. Well, actually, let's subtract first, sorry. 25 is 0. Then we bring down the 2.
Yep.
How many times does 5 go into 2?
Add a
0.
decimal place.
Well, we could add a decimal place and continue.
It's just one. It's the solution.
It's one more? Okay, well, yeah, you're right, because it would have to be, because then it's a multiple of 5. Let's just do that then. Okay, let's bring down a 0, but we do need a 0 for a placeholder in the fact that, like, it couldn't, right, divide in. How many times does 5 go into 20? 4. Okay, so does this look familiar, that whole process?
Yeah.
Okay, I like having a problem like this off to the side, because I'm going to reference back to it, because we're going to do the same thing, but with polynomials. Because why not throw in letters? It's more fun. Right? It makes everything better. It's like you're juggling 2 things. And that's not enough. Let's just throw you another one, and another one, and another one. Okay. Ready? Alright, let's talk about what these are. First of all, let me actually write it like this. So you've got something being divided into something, and you get an answer. Your answer is called the quotient. So your result of all this business is called the quotient. And remember, that's where your answer lives on top. The thing that's dividing in is called your divisor. The thing that's underneath is called your dividend. And if we hadn't continued going to get our decimal, what would I have? Do you remember the other word we sometimes use? Remainder is another word. That's for our leftovers. So we can sometimes have a remainder. So a remainder, again, is your leftover when you're dividing. So those are kind of your key words. So if you hear me use any of those words today, I just want to make sure you know what they mean. The thing out front is your divisor. Thing underneath is your dividend. The thing up top is your quotient. Alright, so in true Miss Bethel fashion, I kind of ignore the steps because that's how I live my life.
Why do you make the notes?
I know, well, actually, I don't make, I theme them and then I use them. Okay. Well, you know what? I will credit Miss Whipple or Mr. Toby or whoever I sold this from.
You don't even know.
I don't even know. I'm that bad of a thief that I'm not even certain.
I feel like we've done this.
Okay. Yeah, you have. Good news. It was awful. Okay. Alright. We didn't like it. It was awful. Okay. So I'm going to show you my way, again, in my true Miss Bethel only child fashion. I'm going to show you my way, the way that I like to deal with it. Okay? So the first thing I do is I take what was in the denominator, which is my divisor, and I put it out front. and then I take my dividend, which is what I'm dividing into, and I put it underneath my division symbol. Okay, now we play the game. Ready? The game is, you look at the first two things. So by first two things, I mean the first term here and the first term here. And you think to yourself, x times what would give me 8x cubed? 8x squared. So if you didn't just think that in your head, step back and take a look and see why your classmates are right. 8x squared times x, would that give you 8x cubed? Yes. So your goal is to make these come out to the first thing here. That's always your goal. All right, here we go. Now we multiply. Remember last time in this example we did 7 times 5 is 35, and then we subtracted, right? I'm going to do that same step right now. 8x squared times x is 8x cubed. Now, because I have two terms, I can't just multiply it to the x and move on with my life. I also need to multiply it to the 2. So 2 times 8x squared gives me 16x squared. Now, again, over my many years of teaching this, believe it or not, this is year 18. If you count my 2 years in Lansing, which I don't know why you wouldn't, I'm on year 20. That's a long time. So over my experience of teaching stuff, what I've learned is that when I tell you guys to subtract, you forget to distribute the subtraction sign. So what I have adapted to saying is that once you get to this step, instead of subtracting, you are going to change all the signs. So this step to me is when I think of changing all the signs. Because if I tell you to subtract, without fail, people forget to distribute the subtraction through. So instead, this is what I think in my head, change all of the signs. And that's what I want you to think too, because again, 20 years of experience has told me that that is the way to go. All right, now we're ready to subtract. What happens to these first two terms? Gone, bye. That's what we were hoping would happen. Negative 3x squared minus 16 more. How much do I have? X squared. Perfect. Okay. Think back to our easier example from a moment ago. What did I do after I subtracted? Bring down the 2x. Okay, so do you see why it's helpful to have that example to reference? Because we really are doing those same steps, just with a twist. Okay? Okay, we're going to play the game over again. This is where we repeat and do it a second time, and a third time, and so on. X times what is going to give me negative 19x squared? Negative 19x. Right? Again, I need to distribute. Negative 19x times x is negative 19x squared. Negative 19x times 2 is negative 38x. Change both the signs. Again, to me it's easier to think that, and I think for you guys as well. So change your signs. What happens to the 19? Bye. 2x and 38x is 40x. Bring down the minus 1. X times what is 40x? 40. Okay, distribute. 40x plus 40 times 2 is 80. Change both the signs. What happens to my x's? Bye, gone. Negative, oh, hold on, I told you. Alright, here we go. Alright, my phone is off. Alright, here we go. Thank you for tolerating my quick phone call from the doctor. Alright, negative 1 minus 80 more is negative 81. So that is my remainder. So I'm going to show you how to write that. So my remainder is negative 81. Now, here's how we write our answer. My answer is 8x squared minus 19x plus 40. Then you're going to add on the remainder. Your remainder was negative 81. And you put it over the divisor, which is x plus 2, the thing that you divided in. And that is your final answer. Now, if it was part of your journey today that you would like to check your work, which I am not going to make you do, but maybe on a quiz or a test you want to, you could take this and multiply it to this, and you should get this. And if you don't, then you did something wrong along the way. Okay? So that's a way to check your work. And again, maybe you don't check work on homework or notes, but maybe you do check it when you're doing like a test or a quiz where it counts a little bit more. Okay, here we go. Part B. All right, what goes out front? What goes in front of the division symbol? X squared minus 2x plus 2. What goes underneath my division symbol? 6x4 plus 2x3. Perfect. Okay.
She's gluten-free bars, that seems really good.
Are they? Alright. I'm glad you guys know so much about my life. Alright, let's play the game. X squared times what gives you 6x to the 4th? What do I want to multiply?
6x squared.
6x squared. Perfect. So 6x squared, let's distribute, times x squared is 6x to the 4. Then I need to distribute here. That's going to give me what? Negative x3 plus 2x squared. Okay. 12x squared. Thank you. Alright. Here we go. So there are two things we can do here. Do you see how I'm missing an x squared term from above? Okay, so what we can do is we can slide this down. So we can do minus x plus 2, and we can put a 0x squared as a placeholder. Do you have to do that? No. But does it leave more room for error if you are just trying to add it and maybe you accidentally add it to this x? Do you know what I mean? So putting a placeholder in is not a bad idea. So I'm going to go ahead and kind of tack that on to my equation here. All right, change all your signs. Change, change, change. Next, what happens to my 6x to the 4th? They cancel. What do I get here? 14x to the 3rd. 0 minus 12, negative 12x squared. Bring down the next term. It's a minus x. So even though we already had a couple terms, we still drop that next term down. Okay, here we go. Play the game again. X squared times what is 14x cubed? 14x. Here we go. 14x cubed minus 28x squared plus 28x. Change all the signs. What happens to the 14s? Yeah. What happens here? And then negative 1 minus 28 more. Negative 29, right? Bring down the 2. Okay, here we go. X squared times what is 16x squared? 16x squared minus 32x plus 32. Change all the signs. What happens to the 16th? Gone. This gives me 3x minus 30. Okay. Now, this is my stopping point because if I come back over here and I try to play the game again, can I multiply x squared by something and have it come down to an x? Right? Like, I guess I could, but it'd have to be like a weird fraction. So that's not what we're going to do. So that's how you know you're at a stopping point, is when you can't play the multiplication game anymore. So what is my solution? 6x squared plus 14x plus 16 plus your remainder all over. What did I put in the denominator?
The under the square minus 2x.
Yep, the thing out front, the divisor. X squared minus 2x plus 2 goes underneath. And again, if I really felt like it, I could multiply this by this, and I should get this, and that's a check of my work. Another thing that you might want to do, and this is just like a helpful Miss Vessel thing, this isn't something you have to do. If you have like a graph paper where it's like the whole sheet is graph, right? Sometimes that's kind of helpful to line stuff up. Do you have to do that for homework? No. But if you're like a very neat and tidy type A person, and you would like to do your homework that way, you sure can. Okay. Now, there's another method for division. Lo and behold. But wait, there's more. Do you also remember synthetic division? This is the one you typically like better. There's a reason we do the long division first. It's because you wouldn't do it if I had already showed you this method. Alright, now, how would we have had so much fun a minute ago together doing long division? Okay, step one. Step one. What would make this 0? What value of x? 3. So the nailed it. Alright, so the first thing you do is write it, and it lives in this little, I don't know, it's on a little ledge. The 3 lives here. Okay. Then, you take your coefficients. If there is a missing term, remember we talked about this kind of on the front page. If there's a missing term, like let's say x squared was missing, or whatever else, we're going to put a 0 as a placeholder for that term. So we're going to steal the coefficients. The coefficients are 5, -2, 1, and -10. Do you notice how I have all of them? Right? So I have all of the above. There's nothing missing, so I don't need any placeholders. But again, pretend this had been gone, then I would have needed a 0. So the placeholders are significant. Then we draw a line down here, and this is an addition bar right here. So this line is where we're going to do our adding. Okay, so what are our steps? We add, and then we multiply. And then we add, and then we multiply again. And we do this as many times as we need to until the problem's done. Okay? Here we go. Add first. 5 plus nothing is 5. Then we multiply. You always multiply by the thing on the ledge. 5 times 3 is 15, and that number goes here. So how did I get here? I took my 5 and I multiplied it by the number on the ledge. That's how I got from the 5 to the 15. So you progress like this. Now I add again. What's -2 plus 15? 13. Then I need to progress over here. So I'm going to do 13 times 3, which is 39. 1 plus 39 is 40. 40 times 3. 120. This adds up to 110. And typically we take our last number and we also put it on the little ledge as well. Do you have to? I mean, no, but I'm going to. Alright, so what do these results mean and how do we figure out our answer? The thing on this ledge is always your remainder. The next thing over is always your constant term. The next thing over is your x term, then x squared, then x cubed, then x to the 4th, and x to the 5th, and so on. Does that make sense? So basically it's in standard form. So your remainder is always the furthest thing to the right. sometimes that remainder is going to be 0. That's great. It means it divided in evenly. Then constant, then x squared. So how do I write my answer to this problem? I'm going to write it up here because I ran out of room. 5x squared, so these are my coefficients, plus 13x plus 40 plus my remainder over the divisor, which was x minus 3. Was that a lot faster than the long division?
So there would be negative 3 on
Is what would make it 0. You're basically solving it to figure out what the solution would be. So there are limitations to this. This is the other reason why I don't show you this method first, is because there are limitations. You have to solve it out for 0, so had it been something that was quadratic, that's problematic, right? So there are situations where this won't work every single time, and so that's why I don't show it to you first, because the other method, kind of like the quadratic formula, will work every single time, but sometimes we can factor. Kind of the same thing here. So this is obviously easier, faster, all the things, but it doesn't always work, and so that's what's unfortunate about it. Let's try another one. Alright, so this time they're just giving me the value. So sometimes they're just going to tell you what it is, and in that case, Durgan, you just plug in the number as is. So do you see how they just gave me the number -5? I'm just going to plug it in. Alright, over here, I've got 4x squared. Do I have an x term? No, so I need a 0 for a placeholder. So that's my 0x. And then here's my constant -3. And again, I'm going to put this little ledge under here. That's where my remainder always lives. Again, you always add first, multiply second. The order is never going to change. Here we go. 4 plus nothing is 4. 4 times -5 is 0 plus -20. -20 times -5. -3 and 100. 97. 4x minus 20 plus 97 over. Now, if the solution was -5, it means it came from x plus 5. So it's almost like you're thinking backwards and you're thinking, well, what would it have come from? It would have come from x plus 5. Are you? I don't know. This is our remainder. This is our constant. This is our x.
Oh, okay.
Okay. Let's do one more of these. The last one I want to show you is how to figure out if something is a factor. Okay? So let's just do part A down here. Is this actually the homework? No. Okay, so ignore that too. So many things to ignore. Great. Okay. So do you see how they just give you the number here as well? So we're just going to plug in 3. So 3 goes on the left. Coefficients. 1, -1, -11, and 15. Draw your line. Draw the spot for your remainder. Now, if something is a factor, that means it divides in evenly. So for example, 9 is a factor of 45, because 9 divides evenly into 45. So we can tell by the factor theorem if something is a factor. The way we can tell is that our remainder is 0. So, something, and that's as specific as I can be because it could be anything, right? Something is a factor if your remainder is 0. So, 3 is a factor, meaning 3 divides in evenly, and truly, what did it come from? X minus 3. So if we get a 0 out, that means x minus 3 was a factor. Here we go. Let's see if it is. 1 plus nothing. 1 times 3. Add down. Multiply. Add down. Multiply. Add down. Was minus 3, so again, think about where it would have come from. Is x minus 3 a factor?
Yes.
So if we divided in x minus 3, it divides in evenly, so it is a factor. So what was my answer? Remember, this is your constant, your x squared. So my answer is 1x squared plus 2x minus 5. Good?
Yeah.
Sometimes, and I can't remember if I gave you one on the homework, they'll ask you to evaluate using this method. It's the same thing. So if they say evaluate for 7, you would just put a 7 right here. And your answer is whatever comes out as the remainder. So if they ask you to evaluate, plug in the number, and your answer is just the remainder.
Wait.
You want me to say that again?
Yes.
If you come across a problem that asks you to evaluate, I'm not going to put it on the quiz or test, but I'm concerned there's one on the homework because I don't remember. If you come across one that asks you to evaluate, the number goes here. And what's here is your answer. And it's the same as if you had plugged it in to evaluate it, right? Like it's the same if you had just plugged in the 2, it does the exact same job. So if I evaluated this equation at 3, watch what happens. I can plug it in. This is going to give me 27 minus 9. Like if I plug this in, this should give me 0, just like it gave me 0 here. Does that make sense? So that's all it's doing. So if you come across an evaluate question, put the number they ask you to evaluate here, and your answer is whatever the remainder spot is. And again, it's the same as just plugging it in. So if you don't want to do it that way, you can evaluate like in the days of yore, and you can just plug it in like you normally would. That also will work. Does that make sense? I will never have an evaluate problem on a quiz or a test. Again, I'm just worried I gave you one on the homework because I don't remember. Assignment 2, page 251 to 252, numbers 15 to 20, 25 to 28. You have to use long division when it says long division. Here's the good news. On the quiz and on the test, it'll say method of your choice. Am I going to make you practice both so you can have a good idea of what you like best? Yes. But on a quiz or a test, you can pick your own method. Does that make sense? So where it really counts